Okay, we're going to continue with our test review. We are on number 5. And 5 can be a tricky question because of the way that it's written, but I kind of want to show you. So it says Alexis wrote 28 minus 20 or 28 minus 8 equals 20. Okay, we know that's true. If we put that on a balance scale, like those yellow ones we worked with the cubes, the ones that look like this, right? It would look like this. 28 minus 8 equals 20. And then she wrote 28 minus 8 plus q equals 20 minus q. Are her equations balanced? So balanced means, did we keep the same amount on either side? Well, the hard part is you're like, well, but it's a q. So imagine it's a number, not a letter. A second. Let's just imagine that it was 5. If I put plus 5, because it said put plus q on one side, and I put minus 5 on the other side, does this remain balanced? Well, let's think about this. 28 minus 8 is 20, plus 5 would give me 25 on this side. 20 minus 5 gives me 15. Is that the same or in balance? No, it is not. So in this case, this is saying if she adds a number and subtracts the same number on either side of the equation, does that make it balanced? The answer is no, because on one side, she added q, and on the other side, she subtracted it. And you have to do the same thing to both sides to keep it balanced. Okay, so you would have to do the same exact thing to both sides to keep it balanced. And she didn't. She did the opposite. Okay, let's move on to number 6. Number 6 says the middle school drama club is planning a picnic. The cost of food for each person attending the picnic is $6.50. The club wants to stay below their budget of $150 for food for the picnic. Write an inequality to represent the number of people P who can attend the picnic if the club stays under its food budget. Okay, so this is a little bit challenging, right? So we know that they want to stay below $150. Okay, costs $6.50 per person attending the picnic. So, and it does say they want to stay below it. It doesn't say that we want to equal it. We want to be below it. So, what we want to do here is it's $6.50, and it says per person, for each person, and it doesn't tell us how many people. It says we have to use P. So we're going to use that variable. So 650 times P times the number of people that are attending is going to give us how much money they're going to spend on food. But we have to stay below 150. So that has to be less than $150. And this would be the inequality we would use to represent the situation. That would be our answer. Okay, let's keep rolling here. Turn it to the back side. We have a multiple choice question for number 7, but there's a lot of words and you have to read very carefully. So it says, during a road trip, Sterling keeps track of the time he spends driving T and the distance he drives D. Which best describes the variables T and D? And so what they're asking you to talk about is the independent and dependent variable. It says the variable D is independent variable because it determines the amount of time spent driving D. So does the distance determine how much time you spent driving? So you got to ask yourself that. Or does the time depend on the distance, or does the distance depend on the time? So let's read our next choices. The variable D is the dependent variable because it depends on the amount of time spent driving T. So does the distance you make it depend on how much time you drive? That sounds pretty reasonable, but read the rest of them. The variable d is the independent variable of t, and the variable t is independent variable of d. So this is saying they're both independent. Can that happen? No. So we know it's not that one. Both variables are dependent variables. So it's saying both are dependent. Also no. So it brings us down to these choices. What depends on the other? So if you think about this, the amount of the distance you go depends on how long you're driving, right? So the distance depends. So this is the one that we want to choose. Okay, next one. We're going to keep rolling with this video. Hopefully we can get this one to the end. A store collecting bottled water for two different organizations is collecting bottled water for two different organizations. Half of the bottles of water collected are given to a local high school band. Complete the table below to show the number of bottles of water B that are given to the band when C bottles are collected in total. So if they have 5 bottles that were given to the band, and that is half of the amount that were collected, that means that 10 must have been collected, because that is, it tells us right in here that where do we go? Half right here. Sorry, looking for that one. Half of the bottles are given to the band. Okay, so if 14 total are collected, how many must be given to the band? So you got to think, well, how much is half of 14? That would be 7. If 18 are collected, that means 9 would be given to the band. Okay, now, but if 11 are collected, or 11 are given to the band, how many must have been collected? So we're going to go the opposite way now. So that means they must have collected a total of 22, because half of 22 is 11, right? And that keeps consistent. And that's all you have to do on this one is complete the table. All right, keep going. This one is more challenging. This is where we found our rate, and we have to find our initial value. Okay, so in this case, right, we are going 10, 11, 12, 13, 14. Our pattern in our x values is it's going up by 1 every time. Y is 20, 22, 24, 26, 28. This pattern is going up by 2 each time. Okay, and remember, to find our rate, we do our change in our y value, so that's the top, over the change in our x value, the bottom. So our rate is 2 over 1, or 2. And then we got to figure out our initial value. So the problem is the initial value is where x is 0. So we would have to work back 10 spots, right? And so you might need your scrap sheet of paper to work back on this one. So you've got, and I'm going to put it here, you've got 10 and 20. So if I work backward, 9, remember we're going down by 2, would be 18. 8 would be 16. 7 would be 14. 6 would be 12. 5 would be 10. 4 would be 8. 3 would be 6. 2 would be 4. 1 would be 2. And 0, where we finally needed, would in fact be 0. So our initial value is 0 right now. So if you remember, what we did is we wrote our equation as y equals, and then we put our rate, which was 2, and then we put that next to x, and then our plus our initial value, so plus 0. Okay, but I do not see any of them that look like that. So remember, we said, do you really need the 0? No. So is there any that look like this? Y equals 2x. Well, again, there still isn't any that really look like that, but look at A. Is it written backwards, and can we do that? It is written backwards, and yes, we can. So this is tricky, because not only do you have to do all that work, but also you have to recognize the answer is actually written backwards than what we learned how to write it. All right. We're going to break it into one more video. So if you need 10 and 11, there'll be one more video after this.